Hi guys, I would like to introduce you to a new book, the C programming language. The book was written especially for beginners and is structured in a way that every theoretical part is followed by a practical programming example. This increases the learning curve enormously and it never gets boring. In total, the book contains 255 programming examples on a total of 351 pages. The entire table of contents can be found at the end of the presentation. Here you can see the back side of the book. In the first chapters, basic knowledge such as dealing with number systems, variables, data types, operators, etc. is covered. Let's now take a closer look at the book, its contents and a few examples. After a general introduction of the C programming language, we start with the first programming example, outputting a text onto the screen. For the first examples, we will first use the online C compiler and then switch to the CodeBlocks development environment, which can be used free of charge for programming in C, C++ and Fortran. If you want to learn more about the CodeBlocks IDE, you can find the wiki and the user manual online at codeblocks.org. Of course, you can also use any other IDEs such as CLion or Visual Studio Code. Here you can see an example of how to calculate the sine of a given angle in radians in a program. Each programming example is also documented in detail in the comments. All program examples in this book are also listed on GitHub and can be downloaded there. You will learn how a compiler works and how it translates source code into a form that can be executed by a computer or microcontroller. Format specifiers are used for input and output purposes. The format specifier allows the compiler to distinguish what kind of data is in a variable when taking input with the scanf function and printing out with the printf function. Here you can see an example of how to use format specifiers with printf. You will learn how to handle binary and hexadecimal numbers, how to convert them to decimal representation, and how a computer handles negative numbers. It is shown how to use variables correctly and how to control access in the program and from other C files. Here an example that calculates the circumference and the area of a circle. Complex data types were introduced with the C99 standard. By including the header file complex.h, the corresponding functions can be accessed to output the numeric values. You will learn about advanced data types such as structures and unions and how to use them. The safe handling of bit operators and their manipulation is especially necessary when programming microcontrollers. Here it is shown how to move bits and link them together. It shows step by step how to install and set up code blocks, which compiler and debugger settings are necessary, and how to use the IDE as a programming tool. You will also see how to work with breakpoints, monitor variables in real time, and display values and addresses from individual memory areas. Control structures like if else or switch case are an important part of programming languages. It is shown how to use them correctly in a program flow. Flowcharts also make it easier to understand the logical sequence of a program flow and to convert it into program code. With the keywords break and continue, it is possible to exit or continue loops in a controlled manner. The break statement breaks the loop immediately when it encounters it. And also, for the iterations like for loops, while loops, and do-while loops, there are many programming examples like here, the calculation of the oblique throw. A commonly used example to illustrate the functionality as well as the problems of recursive functions is the computation of Fibonacci numbers. Here it is shown how the calculation can be solved without and with the help of recursive functions and where the advantages and disadvantages of these approaches are. Functions are an important part of structuring code and controlling access rights, not only in C but also in other programming languages. How to use functions correctly, control access rights and use the passing of parameters, you will learn here. Functions can be called in two ways. A distinction is made between call of value and call by reference. These two calls differ in the type of values that are passed to them as parameters. In this chapter, you will learn where the differences lie and when you should use which method. In the C programming language, an array is a basic data structure that allows you to store a collection of elements of the same data type under a single variable name. Arrays are very important and are used to efficiently manage a group of related values, making it easier to perform operations on the entire collection of elements. Whether you're working with integers, characters, floating point numbers, or user-defined data types, arrays are a versatile tool for managing and manipulating data in C. Here is an example of converting a decimal number to a binary number using an array. In C, we can also create an array from arrays called multidimensional arrays. Multidimensional arrays in C are commonly used to represent data in two or more dimensions, such as rows and columns. These arrays provide a natural way to work with tabular data images and other structures that contain multiple layers of information. Pointers are a fundamental concept in C that allows efficient memory management and advanced data manipulation. Pointers are essential for tasks such as working with arrays, implementing data structures, and working with hardware. While pointers are very powerful, they also require careful attention to memory allocation and deallocation to avoid problems such as memory leaks and segmentation errors. Mastering pointers opens the door to a deeper understanding of C and opens the possibility of writing more flexible and efficient programs. In the C programming language, memory management plays a critical role in determining how variables are stored and accessed during the execution of a program. Two main areas of memory allocation are the stack and the heap. Where exactly the differences are and what you have to pay attention to in order to avoid a stack overflow is shown in examples. Structures and unions in C provide powerful ways to organize, manipulate, and represent complex data. Structures let you group variables in different types, while unions let you efficiently allocate memory for multiple data types that share the same memory space. Both structures and unions are fundamental tools for creating flexible and efficient data structures in C programming. So guys, that was a quick overview of a small portion of the book's content. Further chapters deal with unions, enumerations, the C preprocessor, include guards, dynamic memory allocation, time functions, random numbers, sorting algorithms, and a lot of programming examples for each topic. I hope you enjoyed the presentation and I could give you an interesting insight. On the last slides you can see the exact table of contents of the book. Thank you and all the best.